Now, I definitely need to blog about the React 19 changes around suspense and sibling pre-rendering. I haven't seen anyone so far, apart from the React core team, who thinks this is the right trade-off. Version 19 isn't out yet, so maybe there's a slim chance to get them to reconsider. Oh boy, this is going to be a fun one. You know that because Dominic tweeted at me as a reply asking me to please cover in a video, which obviously I'm going to do. Thankfully, I took my time because I was busy at conferences and stuff, and as a result, he's already written a blog post that'll be a very handy reference, as well as Gabriel, my lead researcher, giving me a bunch of useful notes for us to reference things throughout. Let's dive in. React 19 in Suspense, a drama in 3 acts. Hopefully not 3 children, because then it's going to take way longer. That was a good pun. I think it's worth first showcasing what Suspense is and what we're talking about here. So let's dive into some code. So I wanted to demo how this currently works if you're not using modern, cool new React stuff. So this is using Vite, using React 18, baseline React, the thing you'd currently get if you npm install. And if I refresh here, we'll see it's starting the queries for all of these children at the same time. And they all resolve at the same time. To make this a little more interesting, I'm going to change the code a tiny bit. Instead of waiting until 5,000, we're going to do 1,000 times props.id. So the first one will take 1 second, the second one will take 2, the third one will take 3. So I refresh this, starting 1, 2, 3, 1 finishes, then 2 finishes, then 3 finishes, then we see all the content. Does this make sense so far? We have the suspense boundary, and as long as any of the children are taking time, it will still show this fallback until they're all done. So I change this from 3 to 30. Now that one's going to take 30 seconds. So the first one does or clears immediately, second one takes another second. And now if we sit here and wait 30 seconds, then we're going to see the actual content. But right now, all of these elements are not rendering. They're sitting there waiting for the data to resolve because that last one is still taking its time. Hopefully this helps make it clear what the power of this pattern is. Specifically, if everything is fetching its own data, each of these components is doing its own work, we can now wait for all of them to be done. But you might have just noticed something interesting. Once this finished rendering, the query's fired again, because what this is doing isn't just getting the data for the component and then sitting on it and waiting. It's getting the promise resolved from the component saying, hey, we're done. And then it throws away the response until all of the other promises have resolved. And then it calls them again to get the new data. So what's actually going on here is it is calling all of these components again in the re-rendering process. But since the data is already there because it's cached with React Query, the second time it runs it, which is when all the promises have resolved, it can get the data immediately, even though it is re-rendering the component in that moment. I can make that a little clearer by putting above here instead of starting query for component, rendering component. I'm gonna knock that down from 30 because that's brutal. So we'll change this to 5. So now when I refresh, rendering components 1, 2, and 3, or 1, 2, and 5. 1 resolves immediately. All of them re-render, ends 5. All of them re-render, now it's showing it. But every time one of the promises resolves, it's actually re-rendering all of the components. So if you have a bunch of components inside of a suspense boundary, each of these re-renders every time any of the components completes its process. So when one promise resolves, all of them re-render. When the next promise resolves, all of them re-render. This can be a bit brutal for CPU usage. Because of the potential implications of how this could affect CPU, they tried turning it off on the Facebook code base. So instead, it would be 1, then the next one, then the next one. I could show you this by going back to the next version I had here. So now we see it renders 1, it ends the query for 1, re-renders 1. Now it renders 2, ends the query for 2, now it re-renders 1 and 2. Then it also renders 5, ends 5, renders 1, 2, and 5. But it does just the first one, and then when it resolves, it does the first and second, and then when that resolves, it does first, second, third. So we go first, then 2, then all 3. This is how React works as of React 19. On one hand, this is nice in terms of the CPU utilization because you don't have to re-render 15 to an unknown number of components depending on how many you're nesting like this. But on the other hand, we now have to wait until one of these resolves before we get to the next one. So if we compare, I'll do this the fun way. I'm going to refresh these as close to the same moment as I can. Going to go for the refresh. 3, 2, 1. Cool. Pretty close. This one resolved in 5 seconds because it only takes as long as the slowest one. But 5 here was blocked by 1 and 2. So this 1 second call and then this 2 second call had to resolve before the 5 second call even started. That's the issue. Because this pattern is better for getting all the data fetching as quickly as possible. but it's also worse because all of the components have to render every single time any promise is resolved. This model's better because the promise is resolving doesn't determine how much re-rendering occurs. That's just going through the components one after another. But if the slowest component is blocked by any of the others, that can break things pretty dramatically. Gabriel's already doing his job well here. That's why we started to see this response. This was just posted in the PR here, testing Canary on a real site. The stuff of nightmares. So glad tkdodo ran into this, or it would have been a production surprise. My hope is that a solution can still be found. He even wrote a small overview. Let's take a look at what Paul Henschel shared here. If somehow you're not familiar with Paul, he's the creator of a lot of the Poimanders stuff, PMNDRS, whatever you want to refer to them as, including everyone's favorite thing to hear me pronounce, Zustand, but also React 3 Fiber, which depends on these behaviors a ton. Hi, we started testing how this could affect our site. We updated React next to Canary on a branch of kidsuper.world. The site uses many models as well as textures. First, we recorded the current approach. It takes about 2.5 seconds to load the .glb models. And where things start to get fun, because people use Suspense for a lot of different things. So here we see all of these things start running and rendering and loading on the network immediately. And then afterwards, a few more. Here is after installing the Canary version. Do you see the issue here? I think this should make it pretty clear why this could be a problem. If you are using Suspense as a way to trigger what you want to fetch and not as a way to wait for things you're already fetching to resolve, you're screwed. What do I mean by that? I can demo this pretty quick too.
80 minutes later.
I just introduced prefetching by hand. I'll show you what that means in a sec. But now you see these resolve roughly the same time. What I did to make this work is a little painful. I added this additional child, data brute force prefetch. And what it does is it uses a custom hook use preload query, which is based on this use prefetch query I got from their docs. This will be in React query soon, so keep an eye out for that because it could actually be useful in other cases. So here I brute force grab from the query client if this thing exists, and if it doesn't, then I go ensure query data, which means I go get the data. And since I do this in this component for all of the values, 1, 2, and 5, they all now get fetched at once because I wrote this custom preload code. And you could do this anywhere. In fact, I'm pretty sure if I move this out, it won't block the rest of the page render. Yeah. So that's not even in the Suspense boundary right now. And once it's done, the Suspense boundary can still resolve immediately. So you can choose where the data loads still. And if you're not actually triggering the data loading inside of the Suspense boundary, you're good. Sadly, no one does this. And the chaos I just went through to get it working should showcase that no one actually does this. Like, it's data fetching in your components is super valuable. It makes so much things easier. Not just data fetching, to be clear. I should stop saying data fetching because it's not just that. But let's say one of these is a giant 3D model that I'm rendering, or it's some data that I'm getting from the user's device, or it's a giant component that is rendering in the canvas that I'm waiting to get data for. That isn't data in the sense it's fetching it from a server to get JSON back, but it's things that take a while to produce. That's when this falls apart, because we're not going to go manually prefetch all of the models for our 3D environment that we're building with React 3 Fiber. We're just going to fetch them in the components, because historically that has worked. If we go back to the scary looking example, theoretically, you could pull out all of these things that you're fetching and put them in a component that fetches all of them immediately. But nobody does that because that's not the beauty of React. The beauty of React is the component says what it needs. And if you can fetch that all like synchronously, you just render all of the components. Cool. Now that we've seen the chaos that exists right now, let's go back to this blog post that actually describes how we got here. This was quite a roller coaster last week. Some things unraveled, some things went down, and in the middle of it, React Summit, the biggest React conference in the world. Hopefully you guys like my talk there. Sorry I had to do it remote, but I couldn't leave the US with everything going on, sadly. Let me try to break down what happened in hopefully the right order and what we can all learn from it. To do that, we have to go back to April this year. The first act, React 19 release candidate. The 25th of April was a great day. React announced the React 19 RC, a release specifically for collecting feedback and preparing libraries for the next major version of React. I was really excited. There are so many good things in that release, from the new hooks to the use operator, from server actions to the ref prop, from better hydration errors to cleanup functions for refs, from better use ref types to use layout effect, finally not warning anymore on the server, and of course, the experimental React compiler. There is so much good stuff there. Better than, how did he just summarize my 45-minute video better than me? Anyways, this release is packed with goodies, and I was expecting to upgrade React Query to see if there were any problems. I was quite busy at the time with work and finishing the Query GG course. By the way, if you're interested in this React Query stuff, Query GG is dope. Relatively cheap for what you get. Try to get your employer to pay for it though, because they should pay for it. It's educational, it makes you better at your job. Anyways, but about a month later, we released version 5.39.0, which is compatible with React 19. And here's the tweet where he announced it. There weren't really any issues to dig into here, so I thought this release is on track to become the best React release since hooks were first introduced. That is, until we noticed something weird with Suspense. Second act, uncovering Suspense. Full disclosure up front, I wasn't the first to discover this. Shout out to Gabriel Valfridson, who, to the best of my knowledge, was the first to spot the new behavior one day after the React release candidate announcement. A ton of great changes. However, this change probably deserves a bigger disclaimer. Code using Suspense with libraries like React Query will get waterfalls where loading previously happened in parallel. Yeah, this is sandboxes showing the before and after, similar to what I just demoed before. It's funny because I saw the tweet and I even commented on it, but didn't think too much of it at the time. As I said, I was quite busy and I planned to look into React 19 later. So after the React 19 upgrade in React Query itself, I continued working on the Suspense lesson for the course. We have one example in there where we're showing how to reveal content at the same time, but still have all of the request fetching in parallel. As shown in the React docs, revealing content together at once. So we have the Suspense, and the assumption here is that these components take time to render, and we want them all to come in at the same time because they're getting data or something. What has since been retconned is the idea that it was implied that all of the data these need were triggered to fetch somewhere else not visible in this example, so that all of these are already fetching data before we put it here, but the Suspense doesn't get resolved until all of them have gotten their data. So this prevents that loading spinner hell I talked about before without blocking the render, theoretically at least. The issue comes when each of these elements is fetching stuff itself, and the fetch is triggered by its render starting. Because the first one renders, and then when it completes, the first two render, and then when those complete, if there was a third one there, it would as well. But since this is a child of that whole separate issue, I don't want to go all the way in on yet. But yeah. As Ricky just said in chat, how it's suspending in those docs is hidden as an implementation detail since it's unstable. Yeah. And here's it being shown here as well. So the example looks roughly like the following. We have these two things showing repo data. Let's say they're fetching from GitHub to get data to show about those GitHub repos. Previously, these would both start getting the data immediately. And once both have finished, then the Suspense resolves. But now the first one goes, and then when it resolves, both render again. So the second one starts after the first one's done. That sucks if you're fetching data in components. The way that this works is that React sees the first child will suspend, so it knows that it has to show the fallback. However, it still continues to render other siblings in case they would also suspend, so that it can collect all of those promises. This is a pretty great feature because it means if each sibling triggers anything async, we can compose our components in a way that they will still fetch in parallel while not triggering a popcorn UI where multiple parts of the screen pop in one after another. The classic loading spinners getting smaller and more present until the page loads. A more complete example might look something like this. We have Suspense at the top that has a fallback that's the loading state. We load the header, the nav bar, main with content, footer, and suspend. And since we have this one Suspense boundary, all of these things can go off and do their thing. And then when the Suspense resolves, it's because all of them are done. No more popping. Awesome. This is an important term here. Fetch as you render, but also leave my Suspense behavior the same. Some or all of those components can initiate critical data fetching and will get our UI displayed at once when those fetches have been resolved. Another advantage is that we can add fetches later without having to think about how pending states will be handled. The footer component might not fetch data now, but if we add it later, it will just work. And if we deem data as non-critical, we can always wrap our component in its own Suspense boundary. So if we decide the footer doesn't need to block the whole page, wrap that with a Suspense. And now when this one resolves, it doesn't matter if this one has or hasn't yet, because we're going to use this Suspense boundary as the representative of that element here. Now, fetching data in our footer will not block rendering the main content anymore. This is pretty powerful, and it aligns with how React favors component composition above anything else. Yes, the ability for a component to own and to do and request all of the things it needs is a huge part of the magic of React. I vaguely remember seeing something on Twitter about Suspense having a different behavior in React 19. So just to be sure, I wanted to try out what we have in the course with the new RC release. And to my surprise, it behaved completely differently. Instead of fetching data for both siblings in parallel, it now created a waterfall. I was so surprised by this behavior that I did the only thing I could think of at the moment. I jumped on Twitter and tagged some React core team members, some of which are here now. Hi, Ricky. Needless to say, this tweet took off, and it started a somewhat heated Twitter discussion. We soon found out that this was not a bug, but it was actually an intentional change, which led to quite some outrage. Yeah, it led to enough outrage I had people spamming me asking me to cover it when I was on an airplane. And I was still tempted to film something on my phone quick. That's how big this one was. So why would they do that? Great question. Why would the React team make this change? It just sounds obviously wrong. There are, of course, reasons why this change was made. And oddly enough, they are meant as a performance improvement for some situations. I know this sounds crazy, but there are absolutely cases where not having this work the way it used to is good. when you have the model with all of the components rendering at the same time, every time one of them completes their async work and it's no longer suspending, all of the other components are forced to re-render, even if they're still fetching data from the previous attempt. Thankfully, most of the ways you would do that fetch are non-blocking, so they wouldn't restart that fetch again. But on the other hand, if the actual component render is what's slow, that's going to suck. So here we have the code that Ricky wrote for us for the demo. This example is different from the one we did before because we have a component that is intentionally slow. We do that by having this while loop that locks it for a second as it renders. So this is the first thing in the suspense boundary, and we're on React 18, remember. So when I click this, rendering thing 3 happens, done, then the rest start. But wait, I thought that React would do this in parallel. It does it in parallel when you hit a suspend. Since this component isn't suspending, it's just slow. That means that the next components can't be checked because the render isn't blocking because suspend. The render hits a suspend and then it stops because it knows it has to wait. So if we had actually, it seems counterintuitive, but if I put this above here, we're not even going to use the query. This just indicates that we're suspending. So this tells React, hey, you can bail out now and not wait for the rest of this to be done because we now know it's suspending. And now it's going to load all these things instantaneously because it hits the suspense earlier. But if we don't do that, we just have the slow component be slow here. This blocks all of the other components from rendering until it is completed because it's not slow because of an async thing. It's slow because it's a slow component. I can switch where it is relative to siblings. I'm pretty sure we can't. Let me check this. Yeah. So again, like if this is last in the children, then all of these will trigger their promises. Then this will be slow. But if I move this to the start, you have to wait before these can start. That's the important part here. But what if we don't want to let this be slow? And again, if I put this at the bottom, what will be fun is every time one of the promises resolves, that thing 3 has to render again. So I'm going to change that from rendering thing 3 to rendering to slow thing rendering and slow thing done. You'll see slow thing rendering, slow thing done. Slow thing rendering, slow thing done. Slow thing rendering, slow thing done. Because every time one of the promises resolves, it has to deal with the slow thing again. So now I switch this to be the canary version. You'll notice something. The slow thing doesn't happen until everything else is done loading. So we don't get the 15 times that slow thing has to rerun like we were before because we're going through these in order. Slow thing doesn't get re-rendered until all the other things have been resolved. We're going through one at a time. So if you had, let's say, multiple slow things, because you're a big app like Facebook, you get to see the loading state immediately, which is important too. See the loading appeared instantaneously? We don't have to wait for that. I'm going to change the return to be slow thing here. And we go back to React at latest. Thank you, Bun, for making this instant. Now the suspense is taking so long to appear, we don't have the fallback because it has to go through all of the children and complete all of their renders before knowing what it does and doesn't have to suspend on. So it's not actually going to show the suspense until it's triggered all those promises. In fact, I don't think in this example it's going to show it at all because by the time all of those slow renders are complete, the data loading has been done for a while. Okay, it shows it for a bit here, but in just a moment, it shows it all. That's the issue with the old model, is that we get a loading state significantly later. And all we have to do is change to the canary, go to the exact same page, and we see the loading state immediately because it hits that suspense boundary and it hits that suspense instance significantly quicker. That's why this is nice. That's why they wanted to make the change. So I actually really like this demo. Thank you, Ricky, for showing it. It does a great job of showcasing why this change is nice because it gets you that loading state significantly faster. Now look at the prefetch example. You get fast fallback and no waterfall. Okay, let's take a look. So we're on the canary. Toggle, we get the loading immediately and we brute force the parallel. So yeah, this is the best of all worlds. Because the slow thing doesn't have to start rendering in order for us to start fetching the data, which would have been the problem previously. And we can show the loading state earlier, but we're still prefetching on click now. We go preload all of the query using query client.prefetch query. So we force those all to start loading. We don't block on it. We just start it. And then we show it. now all of the promises that these are waiting for, they're happening already. So these don't trigger the promises. So we can show the suspense significantly earlier as well. Thank you for showing us a blazing fast example, Ricky. If your component is slow because it has to render a bunch of React and a bunch of JavaScript and it has a bunch of things it's touching, having every component re-render when any component finishes is bad. But if your components are slow because they're triggering async things when they are rendered that they have to wait for, then this change is terrible. But that's the issue. On one hand, if you have individual components that take a while to render for reasons other than something they're getting asynchronously, maybe it's rendering a giant table with a ton of rows. If that has to re-render every time a sibling's promise resolves, that's going to be terrible for your CPU. That's going to take way more power to the point where when I was trying to demo it, my browser was freezing. I had to close Arc like 4 times trying to showcase this. But on the other hand, if your components are slow because they're getting data from somewhere or they're fetching some asynchronous data like stuff from your devices on your computer, common case I do a lot, if it's slow because the promise takes time, then the old way was much better. If it's slow because the components take too much time, this new way is significantly better. So if you're, let's say, I don't know, the company that made React, Facebook, and you use Relay to prefetch all of the data way earlier, your components aren't what triggers the data fetch. So it doesn't matter what order you render them in. The thing that is slow is now the component's actual rendering, which is a huge difference that I don't think is properly appreciated here. If the components already have the data coming in, you just want to minimize re-renders. That's what the goal of React 19 was here. But if you are fetching the data in the components, this breaks everything, with massive waterfalls. As we were showing earlier, this great GitHub issue somebody opened where they were using Suspense to fetch 3D models. Previously, if you had 15 children, all of which were triggering a fetch for a 3D model, they would all go render, and then it wouldn't make additional changes until it has all of them, and it'll show you the suspense for all of them. With the new model, each of them has to be fetched before the next one starts, and you end up with hilariously longer load times here, like absurdly so. That's the issue. Here it took under 2 seconds. Here it takes almost 4 seconds for the same experience, just with the change to the new React version. Chaos. Here's the actual issue from good old ACD Lite on the actual React GitHub, describing why they did this. Today, if something suspends, React will continue to render the siblings of that component. Our original rationale for pre-rendering the siblings of a suspended component was to initiate any lazy fetches they might contain. This was when we were more bullish about lazy fetching being a good idea some of the time, when combined with pre-fetching, as opposed to our latest thinking, which is that it's almost always a bad idea. I'm happy that this phrasing is here. Thank you, Gabriel, for linking this, because for data fetching, sure, but there's other types of fetching, like a component in a 3D environment that has to load a model. You don't want to prefetch all of the models because that's a lot of data, and you don't want to do it in a weird hoisting pattern because it's way worse DX. The magic of something like React 3 Fiber is you get the composition primitives of React, you get the suspense and the parallelization of React as an interface to get other things in, which is so powerful. And I really hope we get some comments from Paul on this because he has really good thoughts. Another rationale for the original behavior was that the render was IO bound. Anyways, so you might as well do some extra work in the meantime. But this was before we had the concept of instant loading states. When navigating to a new screen, it's better to show a loading state as soon as you can, like a skeleton UI, rather than delay the transition. There are still cases where we block the render when a suitable loading state is not available. It's just not all cases when something suspends. So the biggest issue with our existing implementation is that the pre-rendering of the siblings happen within the same render pass as the one that's suspended before the loading states even appear. What we should do instead is immediately unwind the stack as soon as something suspends to unblock the loading state. That's a noble goal. How quickly can we show you the loading state? So if we can figure out really quickly, hey, this component's suspended, we need a loading state, get you that immediately, then go deal with the rest later. But yeah, this is a lot crazier as we go deeper. If we want to preserve the ability to pre-render all of the siblings, what we could do is schedule special render passes immediately after the fallback is displayed. This is likely what we'll do in the future. Good to know they had a plan for this. However, in the new implementation of views, there's another reason we don't pre-render siblings, so that we can preserve the state of the stack when something suspends, and then resume where we left off when the promise resolves without replaying the parents. Yeah, this is another key piece, as I was showing before. Things get replayed a lot with the existing suspense model. The only way to do this currently is to suspend the entire work loop. Fiber does not currently support rendering multiple siblings in parallel. Once you move on to the next sibling, the stack of the previous sibling is discarded and it cannot be restored. We do plan to implement this feature, but it will require a non-insignificant refactor. Again, since whenever one child resolves, all of the children re-render, you lose any state that existed in those render passes, which is brutal unless you're handling that externally through something like using external store and the crazy stuff that React Query is doing. But with an ecosystem that already exists that has successfully built working primitives around these behaviors, it is nice to think React will have good enough defaults built in the future, but breaking the existing workarounds is a terrifying thought. Given that lazy data fetching is already bad for performance, the best trade-off for now seems to be disabling pre-rendering of siblings. This gives us the best performance characteristics when you're following the best practices, like you're hoisting data fetches to server components or route loaders, at the expense of making an already bad pattern a bit worse. Whether or not we agree it's a bad pattern, this isn't a bit worse. This is 2x worse. This is really, really bad. This is not good. So I understand why this got downvote bombed. I also understand where they're coming from, but this feels a little too much like idealism with what React should be, not realistic with where React is today. Later, when we implement resumable context stacks, we can re-enable sibling pre-rendering. Though even then, the use case will mostly be to pre-render the CPU-bound work, not for lazy fetching. Good context. Here is Paul Henschel showing up. I knew he'd be in here. Is it possible to still talk about this? Making this a waterfall will have an impact that would push everything that relied on Suspense at an immediate disadvantage. Not just on the DOM, like React Query and such, but also platforms like 3 via React 3 Fiber, which are inherently async. Everything is a fetch or an async worker in WASM. Userland workarounds like pre-catch don't apply to non-user facing async tasks and third-party modules. It can't be put into global space because it would break tree shaking entirely. And like Kapach mentioned before, it also breaks encapsulation. It would also diminish encapsulated async composition and interop, a major groundbreaking feature in current React. There are actually some great talks Paul Henschel did showcasing how with the current not ideal version of Suspense, there are things that just could not be done in any other framework. It's why he built React 3 Fiber in React and not in something else. In this example, we have center with async thing A and B. Center knows when async thing A and async thing B have completed, and it can act upon it in its use layout effect. React 19 would first load async thing A and then async thing B, adding potential seconds to TTL. The user would be forced to break component encapsulation and pre-cache, which means the contents of center can no longer be dynamic or conditional. But if contents are third-party async components, it's over completely. The loss of this capability cannot be understated. Please consider undoing or making the behavior opt-in or out. Suspense lists reveal order would be a very useful fix. This is actually a good call. Reveal order, forwards, backwards, or together. Good call out. As per usual, Paul Henschel is absurdly smart and makes my brain hurt when I read what he says, but it's valuable. Let's quickly read what was said here by TK because it'll be useful. Let's assume that expensive component takes some time to render. For example, because it's a huge subtree, but it doesn't suspend itself because it's just a slow component. It's not a blocking component fetching data. Now when React renders this tree, it will see that suspending component suspends. So the only thing it will need to display eventually is that suspense fallback. However, it can only do that when rendering is finished. So it has to wait until expensive component is done rendering. Even more, the render result of expensive component will be thrown away because the fallback has to be displayed. This is another important key. When a suspended component resolves, if it still has children that haven't finished, that response that you get gets tossed out and then regenerated when all of the suspense boundaries are cleared. And once all of the things suspending have resolved, that's when we generate the actual response. But until then, you're kind of fucked. When we think about it this way, pre-rendering the siblings of a suspended component is pure overhead, and it will never amount to a meaningful output. So React 19 removed that to get instant loading states. Of course, if you suspend it instantly, you can't see that the siblings will also suspend. So if the siblings were to initiate data fetching, like with use suspense query, they will now waterfall. And that's where the controversy comes in. Fetch on render versus render as you fetch. Having a component initiate a fetch is usually called fetch on render. It's the approach most of us likely use on a daily basis, but it's not the best thing you can do. I like this call out here because yes, this is how most people are fetching right now, and it is not ideal at all. One thing I will add is that use suspense query as a primitive in React Query is probably one of the less used ways to fetch data. And usually when people are using React Query, they are fetching as you render. So you do the fetches in the components and each one owns its own loading state, so they don't suspend at all. Even when siblings inside the same suspense boundary are pre-rendered in parallel, you will not be able to avoid the waterfall if you have two use suspense query calls within the same React component, or if you have a parent-child relationship between the components. That's why the recommended approach by the React team is to initiate the fetches earlier, like in a route loader or in a server component, and then to have the suspense only consume the resources rather than initiate the promise itself. So you think about promises as having two sides. First, you have to trigger it, and then you have to get something from it. If the components are just getting things from promises, this new model makes a ton of sense. But if the components also trigger the promise, that's where things get messy. So here's an example where we're fetching the data ahead. If we prefetch the query data, then this new model just makes the components cheaper to render effectively, and we can see the suspense earlier. However, no one actually does this. Very, very few people are going out of their way to manually cache React query data ahead of time before we start rendering the components, because otherwise we wouldn't even be using these patterns in the first place. But hopefully this helps clarify the fact that the components not triggering the promise means this is a non-issue, but if the components trigger the promises, that's where the issue starts. Here, the route loader makes sure that the data fetching occurs for both queries and that is initiated before the component is rendered. So when React starts to render the suspense children, it doesn't matter if it renders the second repo data component or not, because it wouldn't trigger or fetch. It would just consume the already running promise. So to show this example again, we have tan stack query and tan stack table, both repos. If these were fetching the data themselves, this would have to complete before this one starts. But since we're doing the ensure query data call here, we're fetching this stuff ahead of time and dumping it in the query client. That means we already have the data loaded, so the suspense behaviors here don't matter. But if we deleted this loader and the components were what triggered the promises, then we're screwed. I really don't like the idea of duplicating logic between where the call is initiated and where it's actually called. That's the icky bit. And that's the thing that'll push you to use React server components for more things. Yeah, in order to do automatic preloading, you need to ahead of time statically analyze the tree to discover the requests you need. Then you can preload them from the client render. That's what Relay does. Or you can ahead of time render the tree to find the requests that you need to preload, which is what React server components does. And if you're doing it at request time, you might as well start those requests too and then pass them down to the client. If you, dear developer, could write, debug, deploy the data fetching parts of your client-side app as easily as you do static apps, then we'd see a lot fewer complaints about the framework pushing you to write performant apps by default. Yes, but good luck doing that for all the crazy stuff that's going on in React 3 Fiber. This works great for fetch, and I think that's the issue. Is suspense for fetching JSON not ideal? Suspense for all the weird things going on in Poimander's land, magical primitive that allows for things that were unbelievable before it existed. Robert had a reply here who Robert has a ton of experience with all things React and has been super, super handy in our research throughout this. He had a lot to say here. Yes, you absolutely need a good developer experience, which means that you need the following. Co-located dependencies like data, JS, and all of the above, and those need to be hoisted, meaning executed before render. And most likely that means a compiler. But you can imagine alternative solutions, such as a solid-like solution, separating constructors from components, or even something like server components, where we don't care about hoisting because things are on the server, which means they're fast. The problem of how to match the logic in your components with the logic that determines what to preload is also a problem. GraphQL is a limited language, so it probably needs extra features before it is a good candidate. Server components are another answer to this. Over and under fetching is also an answer. Yeah. All good points. When to fetch is a tough problem, but if we're not fetching, if we're getting data for other things in other ways, then stuff starts to fall apart. Manually hoisting is the solution that everyone has in their heads, and the reaction is, that's hard, and that's correct. Why did that not work? Did I put that in the wrong one? It should be stable, shouldn't it? Okay, that's fucking brutal, actually. I'll change that to just be use query then. Theoretically, no. I used the wrong thing there. I'm confused. Somebody have a demo of this already? So theoretically, with all of the custom code I just wrote, this should finally work as expected. Nope, still blocking. Great. The long-term solution will not involve manual hoisting. Manually hoisting is a nightmare at scale, at least without linear types. There's nothing guaranteeing that every resource you load is actually used by the subcomponents in your tree. So you'll end up loading more resources than necessary, especially for complex UIs. This isn't just a problem when we're manually writing route loaders. It's also a problem when writing REST endpoints that bloat over time for the same reason. It's also a problem when you call useQuery once at the root of a given component tree, which one must do now for performance. Over time, that useQuery call will fetch more data than the tree even needs because it's easy to add fields, but it's dangerous to remove them. So to break down what he's describing here, if we have a bunch of components that we want to have fetching their data in parallel, so we put it all in one giant useQuery call on top, what happens if somebody deletes one of the components that had one of those data fetchers in there? Do we know all of them are gone? Do we have a way to determine which things aren't needed anymore? A more relatable version of this problem might be CSS. If you have a bunch of CSS files where you wrote a bunch of CSS, how do you know for sure that nothing is using the old CSS class names in your code base? If you delete the component that you thought was the only component using that class name, can you safely go delete the class name and everything related to it in the CSS? The number of stale classes that exist in a code base like Twitch, for example, where we have a CSS class that is no longer being used because it's for an old feature that got deleted, but we're scared to delete the CSS Now imagine that for your data fetching. That's what's going to happen here. The question of how to keep the logic of what to load in sync with what's in your components is the very important question we're trying to resolve here. How do we get the data that the components need while also not making it harder to write the components and the data layer without overfetching or underfetching? How do we get the components to know at a route level what all of the potential data is so that it can all be loaded immediately as the components appear as the data appears? This is a very speculative solution, but I think the answer involves the following. No redundant conditional logic in your components. Instead, your components will be passed some component or null, or some resource or null, and whether that is null or not is determined at the route level. There will be a statically analyzable language that is powerful enough to encode all the logic that you use to determine what data is needed by any given UI. And overfetching and underfetching are escape hatches for this. This language is used to select not just data, but also JS resources, translations, lazy loaded components, you name it. So it's not just GraphQL. And potentially some static analysis that ensures that if you use a given resource conditionally, that condition is understood by the compiler. So for example, this is allowed where we get data variables and runtime props. If variables.shouldLoad return data.myComponent, but this wouldn't be. Data variables, runtime props. If runtime props.shouldLoad return data.myComponent, because we have these props that exist at like the compiler level, determining what components need what data. And then runtime props is a separate thing that exists in runtime land and JS on the client land. Separating the data props and the hierarchy of those in your graph from the state stuff, that sounds chaotic. I see why we want that, but that sounds pretty rough. Apparently, he did a presentation in GraphQL Conf last year about what this could possibly look like. But that's, again, just for the data fetching part. I'm sure he hacked some crazy stuff for the React and JS parts there. Take notes of what he didn't mention. GraphQL, JavaScript, URLs and routes, and React. All of those are implementation details, and everything above applies equally well to any other UI, at least where there are servers involved. I like the call out here of at least where servers are involved. Good stuff. Shout out to Robert once again for putting this all together and helping us clarify what we want to talk about here. It's important for us to have good solutions to hoist the data fetching, but not everything is a fetch, as TK says here. Hoisting your data requirements is a good idea regardless of how Suspense works, and I also recommend doing it. However, with the proposed React 19 changes, it becomes almost mandatory to do so. Further, if I learned anything from React Query, so not every async operation is a fetch. I'm one of the ones who push this really hard. I use React Query for a lot of things that aren't fetching. For example, using react.lazy for code splitting would also mean the bundles are loaded in serial if your app looks like this. So we have a bunch of components that are lazily loaded, or maybe you're using module federation or some of that fun shit, where the component starts to get its JavaScript lazily. Now this has to get its JS before this starts to get it, before this starts to get, before this starts to get. This is terrifying. Yes, you can technically preload the dynamic imports as well, but making this required for good performance kind of defeats the purpose of React Suspense and component composition, as the app component would need to know everything async that goes on in any of its children. Yeah, this waterfalling is terrifying. So to showcase how different this is from how we felt before, here is Paul Henschel talking about Suspense in React 18, which is the way it used to work and how excited he was about that. Since React 18 is coming, I'm compiling some tweets exploring Suspense, a groundbreaking new feature. Suspense allows components to handle async tasks, while the parent controls the loading, errors, and fallbacks. It is essentially solving async in front end. Here are some use cases. Example 1, you load an async asset, fetch, wasm, parsing, workers. When it's finished, you want to execute a specific action, for instance, a zoom in. So here, once the data is loaded, on that load complete in the suspense boundary, he can trigger a zoom, which just looks awesome. Since model is async and zoom in, which is not, share the same suspense boundary, zoom in will not execute before the model is ready. This is literally all you have to do. So you have suspense, fallback, zoom in, model. Example 2. One component is async, while the other needs to operate upon the result of it. Same thing. If both share the same suspense boundary use effect in the opening component, it's guaranteed to be able to access the async reference. Example 3. You want fallbacks. This would have been hard already, but imagine going through variants where you want to load a lesser thing first before switching to the high res. Sketchfab does that, for instance. This is how easy it is to get through progressive enhancement with React Suspense. Loading indicator, low quality, then high quality. So we take a look at this code. We have this big suspense on top where we have the fallback, which is this loading state. But we have another suspense in here. This suspense that is a fallback of the low quality version of this model. So this one takes less time to load because it's lower quality. But since this takes time to load, this suspense returns something that this suspense blocks on. Since we hit the suspense because it's taking a while, we return this thing, which also suspense is going to take some amount of time. But now, whichever of these resolves first is what triggers there, and we have this loading state up until then. So we get loading state, we go through, we trigger this, We realize this takes time, so we trigger this. And then if this resolves, this will clear that loading state. And then when this resolves, it will clear this state, which is effectively a mini loading state. This is so cool that you can suspend with a fallback that triggers the suspense above, knowing that one will take less time. This type of composition is just incredible and really showcases the magic of the new React model and the power of suspense. So here's the demo with the audio stuff. We have suspense that has this positional audio and it has the analyzer. This won't become part of the page until both of these have resolved. This might exist in the JavaScript world, but it doesn't appear as part of the content until the suspense has been cleared. So we need the positional audio, which has the files, I'm assuming, to load, which takes some time. The positional audio, that's one of their components, yes. So it has to load the audio file, which takes some amount of time, and also has to load the analyzer, which is going to load way more additional stuff. So both of these can now run in parallel. We could both be getting the data for the analyzer and fetching the audio for the positional audio component. And then when both are ready, both render at the same time. Super cool. Yeah. The audio play triggers when everything is loaded. So if one of these took longer than the other, that's fine. They both trigger at the same time. Super cool. This is all the code it takes to go through 3 stages. Loading indicator could be any other component, of course, like a block or a sphere. So here we have some HTML, that is the loading. Then we have this, which is the next state, and then the final model, which is what we actually want. Or since they all render at the same time, it's composable, it's magical, it's the thing that we all love React for. By the way, yes, the above demo does have a waterfall because I want you to see the loading in DevTools with disabled cache. All you need to do is call this preload calls, and the loading happens in parallel. Okay, this is actually funny that he tweeted this at the time. Because this would solve about half of the issues we're mad about right now, but still, yeah. Reddit is going through the suspense debate currently, and there are some that say, too bad you used an anti-pattern, or why not wrap every suspending component into a suspense bound if you don't like waterfalls? The snippet shows what would be lost. I can act upon the results, async A and B. I am sync, but I show up when everything else is loaded. So here we have this ref that is being shared between the children. Use layout effect, measure contents before they're painted on the screen. The view could still be altered based on the results. Do something after. So what happens with this code in React 19? It will waterfall. Async component A completes, then async component B, and so on. This would create a long wait. If you don't want waterfalling, you have 3 options. One would be go back to use effect, trigger all of the async stuff, set state when you're ready. Kills interop, no parent outside will be able to act upon the results. There can be no overall fallbacks, only individual ones. 2 would be you could wrap each async component in a suspense, which kills the interop. There's no parent outside for that we can act upon the results with. There can be no overall fallbacks, only individual fallbacks. Why bother with suspense at all over just using use effect and set state? Or we can break the encapsulation and pre-cache all of the async stuff. The contents could not be dynamic or conditional any longer. This would not work if the async components are pulled from a third-party library. One of the most powerful features that React has to offer would be gone. So here we have suspense, carbox, and zoom. Zoom use frame does the zoom, and it waits until these other things are done. So we load the car, we load the box, and then when all of that stuff is done, we do the zoom. Super simple, super nice. Apparently there's a diagram in this. That is actually very handy. React triggers the suspense fallback, which then fetches the car stuff, throws a promise. We're now waiting. Here, we show the fallback. And then when all of the things that have promises have all resolved, then they all get rendered in the DOM. Super cool. Thank you for the diagram. So we've talked a lot about this. What we haven't talked about yet is the response from the React team, which seems like it would be important. And I'm sorry for dragging you along this long without doing that. Let's start with the first response. This one was admittedly pretty quick. So this was June 11th at 11 p.m. And Sophie jumped in about 12 hours later because they immediately had a meeting and chatted about this. Discussion at the React Core team meeting today. Hey, Sophie, we don't call it React Core anymore. It's just React team. You're better than this. This was not motivated by server components or Vercel, but actually the Facebook site, which is faster this way due to less CPU load. As I mentioned before, if the component render is what's slow and you've already parallelized your data, this change makes sense, but for everyone else, not so much so. The simplification enabled several newer changes, and it would need weeks of work to put back, even if desired. The proper fix is a major refactor to be able to track multiple in-progress components without re-executing unnecessarily, so that we can have the best of both worlds. Until then, we're left with 2 suboptimal options. Recognize the old way is better for React Query users with lazy fetches, or that the new way is better for teams that have already structured their code to initiate fetches earlier. Folks with hyper-optimized performance have already done this, and now they have a higher ceiling. I think our documentation today around how to structure your fetches / when to fetch, if not using a server, is not good enough, and this needs to be fixed. I pushed the team on this. I agree. We showed the docs earlier. They did not make this clear, to say the least. Ultimately, I recognize your frustration, and I feel frustrated about this too, but also recognize that there is no easy fix that is better for everyone. I wish I had better news to report, but hope this context helps a bit. And then 2 more days passed and we got this response. Good news, Suspense. We just met with Ricky, Joe Savona, and good old Andrew Clark, ACD Light. We care a lot about single-page apps. The team misjudged how many people rely on this today. I'll say twofold here. On one hand, the average React dev doesn't know about any of this and has no idea this is going on. But the people who are really deep, the people who use React for things that aren't just traditional websites like video call apps like Ping or crazy 3D experiences you'd build with 3Fiber, there's more of those people doing more of these things than I even knew about ahead of time, much less them, which is understandable. It's a weird case, and it's certainly not the average React user. But there are still more people doing weird stuff with React than there are people doing anything with Solid. So it's important to know that these people exist. And they're also the diehard, crazy fans of React. There are a few people who care about and understand React better than Paul Henschel. And pissing him off is never a good idea. If you can avoid angering Paul, it will probably benefit the whole ecosystem. But they absolutely misjudged, and they're not pretending otherwise. It's cool to see them say that. Most people would be like, well, we hear you, and we're going to do our best to make sure we make everything good for everyone. But they specified we were wrong here. We made a bad judgment call. They're still going to recommend preloading, but they recognize it's not always practical. And they're going to hold the 19.0 official release until we find a good fix. Huge. So good. This is why we have an RC process. We're going to wait until this problem is solved. For those who don't know Joe, he's the person who is largely leading the efforts on the compiler side, and a lot of his history comes from building crazy stuff with Relay at Facebook, so he deeply understands data loading in React more than almost anybody. So Joe is intimately familiar with how to do data fetching and async suspense stuff correctly in React. I was lucky to have a really good conversation with him and Tanner, and when I say I had a good conversation, I mean I watched them talk, and I just made them speak. His depth of understanding of how libraries interface with React is surreal. And I was hyped that he was one to jump in on this. I think Joe is one of the better people to communicate with these library authors about these things. And I'm pumped he jumped in. Some thoughts on the suspense changes from the 19RC. Most important, our bad. We got this one wrong, and we heard and we sincerely appreciate your feedback. Great opener. Starting with that, starting with the apology, and then going in. This is A+ comm stuff. Everyone should take note of this, especially if you have things that anger people. So what happened? The behavior change affected a specific case, a suspense boundary with multiple children that suspend. In 18, React wouldn't stop rendering at the first suspending child, and it would continue to pre-render those siblings. We regularly analyzed performance of React apps, and we found that this behavior was inefficient in apps that were using the render as you fetch paradigm. In this approach, you fetch in something like a route handler, and then you suspend if the data isn't ready yet in render. So the render as you fetch, to be very clear, means you fetch ahead of time, and then you render things when they're done. When using this pattern, it was inefficient to try to render other siblings of a suspended child, since we would have to show the fallback in either case. So for React 19, we changed to show the fallback right away, then render the children again once a child unsuspends. We extensively discussed the trade-offs of this change. We knew it could regress in a specific scenario, apps with many lazy fetching children in a single suspense boundary. Yeah. We thought this case was uncommon enough, so we decided to ship and get feedback. Again, wrong in hindsight. Lessons learned, a lot has improved over time. When things went wrong is the next step. We hoped that we'd get feedback via the Canary release, which has included the change for many months. But during that time period, we've also learned the Canary channel isn't easy enough to consume, and very few were testing with Canary. This is a huge learning. I was going to bring this up earlier, and I'm very thankful that he did, because not a lot of people test this. The fact that tkdodo caught this prevented the web from getting slower. So once again, I hope I've shouted him out enough. Check out tkdodo EU, give him a follow, buy his course. He just saved us from so much pain. So much pain. Thank you, TK, for doing the diligence to check this, test this, and advocate for this in a way that allowed for the whole ecosystem to improve. The result of this was that we didn't get the feedback until the 19 release candidate. Our changelog did call this out, but they could have called it out more prominently, and that's how folks knew to test the behavior. Once we heard the feedback, we quickly discussed, leading to where we are now. Stepping back, there are a few things going on here. We need to continue fleshing out our story for client-side data fetching. But there are many great options in the space that support the render as you fetch pattern. More important is getting feedback from the community earlier. This is harder than it seems. It always is. Because of the size of the community and the many ways people use React, we need to balance info overload while getting a diverse representative set of feedback. We also don't want to privilege established players at the expense of making it hard for new libraries, frameworks, educators, and voices to emerge. Rushing into a fix could backfire and lead us down the wrong path. Joe, why is Joe so good at this? It's his job to write the code. This is one of the best, publicly take the L and learn posts I've seen in my entire career. So we're working on changes to get the feedback from y'all earlier. We're exploring a number of ideas, including evolving our previous working groups and RFC process. We will definitely also reevaluate the Canary process to ensure that more developers can try out changes and new features at an earlier point. This is great. So much ownership, so much clarity. Yeah, I'm happy they're walking it back. So here is TK's response to this third act, the escalation and delaying of the release. By now, a lot of people on the internet were surprised about and afraid of these changes. Screenshots were shared about how apps that fetched almost everything in parallel in 18 resulted in a total waterfall in 19. The developers behind the Poimanders open source community, which maintains React 3 Fiber, were a bit freaked out because a lot of what React 3 Fiber is doing is based on async work, and it leverages how Suspense works today. This went so far that even forking React was up for discussion if the changes actually made it into version 19. By that time, I was already in Amsterdam for React Summit. We were talking about this change at the React Ecosystem Contributor Summit, where everyone was either surprised, concerned, or frustrated. The React core team was doubling down. Kind of. They were saying that, okay, this is bullying Ricky. I get why they like bullying Ricky. Which is better? For fetching, duh. But again, places that aren't fetching doesn't necessarily make sense. If you can't move the request all the way to the top, not great. I see why people were upset with this. Love you, Ricky. You're easy to bully. Yeah, you're easy to bully. Specifically, the React team members were saying that we should hoist the data requirements anyways, which, yes, we should. And also that we never made Suspense on the client official. And as I've heard this from a lot of people on the React team, that Suspense wasn't right until it was server-side Suspense. If you use Suspense along with streaming for server stuff, that's when I first started to heavily use Suspense personally. But yeah, if you're using Suspense because you're a Poimanders dev or you're building on top of their stuff, you're already all in on Suspense. But like, I learned Suspense through Paul Henschel. I later got good at Suspense through server components. Okay, Suspense was stable, but suspending was not. Do you see why I hate your naming so much? Do you understand how hard it is for me to explain this to the people watching this video right now? Which is why I'm going to politely ask you to subscribe to this channel, because this video has been a lot of work for not just me, but my whole team and everybody else joining in on it. And if you think I should do a longer video about Suspense and its history and what Suspense versus suspending and all these things means, let me know in the comments, and please subscribe. This has been a lot of work. Later that evening, I had the chance to talk to Satya, who worked on the React compiler as well as version 19. He assured me that the React team cares a lot about the community and that they likely underestimated how the changes would influence client-side Suspense interactions. On the next day, the React team met and decided to hold the release. Again, 12 hours later. Very, very soon after. Great response time overall. It's very reassuring that the React team is open to feedback at this stage. Postponing a release that was already announced and presented at a conference is a big move, one that everyone involved really appreciated. I'll gladly work with the React team as best I can to find a good compromise in this matter. Okay, this is a good comment from chat. If the 19 release happened now, our customers would have our heads. We have forms that display dynamically different components, which have Suspense boundaries with several dynamic fetches depending on user inputs from the parent components. Having everything in waterfall would affect performance to smithereens. Yeah, there are a lot of weird edge cases that weren't considered with this change. The biggest React nerds are the ones who are adopting Suspense early, which means the deepest React community members are the ones who have this break for them. Learnings. There's a couple of things I learned from all this. For one, trying out early releases before they come out as a final version is a very good idea, especially if the team is ready to take feedback and act on it. Kudos to the React team. I just really wish I would have given the feedback earlier. Again, everybody's being so reflective here. Like, TK, to be clear, you did everything right. Nobody would have thought to go check these things unless they were deeply reading these notes. And for this to come up a while ago, you to see it, not think about it, and then find it later, and still be the first one to bring it up, huge. But yes, as a community, we should make it an effort to test these things earlier and find these things earlier. The fact that there are so many things changing in React 19, and this is the only thing that would have broken, at least that we know of, is massive. But if we could find this thing earlier, then this could have been a seamless upgrade. The other thing that became obvious to me and the other maintainers is that we need a better channel to communicate with the React team. The React 18 working group was probably the best thing we had in that regard, and the whole saga showed that having something similar for React 19 and maybe future React releases would be great. Something like a permanent working group maybe. Also, obvious but worth mentioning, shouting at each other on Twitter is not helpful. I regret the part I took in any communication that wasn't calm and objective, and I really appreciate Sophie's way of communicating and handling things. Yeah, Sophie and Joe are the real goats here. Like so many others before me have figured out, interactions in person are always so much better, and I'm looking forward to having more great conversations at conferences. Thank you, TK. I'm happy that this is resolved. I felt strongly for a long time that React needs a permanent working group on a platform that allows for instant communication. For the love of all JS, just use a private Discord. I know they can't take on a fully open communication path with the public, but this would at least cover a very underserved gray area and give supporting ecosystem voices, authors, and maintainers a place to communicate up the chain that isn't email, in-person conferences, events, in the small percent of React stewards who are active on X and Twitter. Agreed. Although I do like the point Joe made earlier that making sure we do this in a way that doesn't just benefit the privileged, experienced, established people is important too. So how do we make the React team accessible without overwhelming them with useless comms, but also accessible in a way that even new devs building new libraries can have a fair voice too? It's a tough balance, and relying on Twitter for it is not working. My hope is that with this debate, the React team will acknowledge that Suspense is also an asynchronous orchestration solution. Whenever Suspense comes up, it's about fetch. But fetch is a DOM construct. Suspense is part of the React library and is built around JavaScript promises. Fetch does not exist anywhere outside of React DOM. Suspense is about more than fetch. It can transform the React ecosystem just like hooks did. It enables components to interop. A parent can act upon its contents. This was impossible before Suspense because no outside parent knew when its contents completed their async tasks. It's a breakthrough compositional ability that would have been lost in React 19. A small collection of Suspense-enabled React patterns. I showed this earlier. Great stuff. And I think they're hearing this now too. We use Suspense for things that aren't just fetching. The result will hopefully be some change on the team culturally. Thankfully, the current figureheads are good enough people that we have that source. It is reliable, and we were able to jump in front of this ahead of time. But honestly, too much of this came down to luck, and I am very, very thankful we've learned as much as we have. I don't have much more to say here, so until next time, peace. We cut to this point, and you don't need to include all of the hell I got to get here.